Hello, my dear students, and the rest of the learners. Welcome to part 35 of a 95-part series of tutorials in object-oriented programming in C++. In this tutorial, we are going to continue looking at the subtopic by the title Inheritance, with our focus being on the effects of inheritance. My name is Meme JM, or you can simply call me Emily Swap. Inheritance affects the size and the behavior of derived class objects in two ways. Number one, an object of derived class will continue all or will contain all the data members of the derived class. However, it will contain data members of the base class also. Therefore, an object of the derived class will always be larger than object of the base class. Number two, with respect to an object of the derived class, we can call the public member functions of the derived class in any global non-member functions. However, we can call the public member functions of the base class also. Inheritance is therefore the process by which new classes called derived classes are created from the existing classes that we call base classes. Just as a reminder, my dear students and the rest of the learners, when we talk about base class, it is the class that contains the data members that the other classes are inheriting or that the other classes are reusing. Or the derived classes are those classes whose members are the members that have been inherited from the base classes. In other words, base class contains the members, both the data and the methods that the derived classes reuse. Inheritance implements what we call an is-a relationship. An derived class can therefore be said to be a type of the base class, just like an aircraft. What we call derived class is a type of a vehicle, that is, base class. A class may contain an object of another class, or a pointer to a data structure that contains a set of objects of another class. Such a class is known as a container class. For example, an aircraft has one engine or an array of engines. Another example can be that of a Mango class, an employee class. A manager, that is an object of the class manager, is an employee, that is an object of the class employee. These are just examples. Nevertheless, it has some features that are not possessed by other employees. For example, it may have a pointer to an array of employees that reported to him. Derived class is also a base class object. And derived class contains additional data and members and is thus a specialized definition of its base class. In other words, what we are saying is that whereas a derived class inherits certain members from the base class, the derived class has the freedom to have additional members that are not found in the base class. Therefore, the process of inheritance is also known as specialization. The following diagram illustrates derivation using a pointer from the derived class to the base class. So in this case, you can see that we have a class called result and another one called scores. So result, the class called result, is relying on some of the members of the class called scores. And with that, we have come to the end of part 35 of the 95-part series. You can now continue to part 36 of 95, in which we are going to be focusing on the rules of inheritance in object-oriented programming. Congratulations for learning part 35 of 95 on effects of inheritance in object-oriented programming. You can thus access videos for the other parts in object-oriented programming series, as well as other computer or ICT videos by clicking or tapping on EmilySwap ICT YouTube channel below this video. Remember to subscribe to the channel by tapping on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write to us through the email emilyswap@gmail.com. Thank you very much for listening to me, and God bless.